Hello students, hope you're all doing well. Welcome to another video by Quick Study. Today we will start another topic of IGCSE Physics, and our topic for today will be sound waves. So what are sound waves? Sound waves are basically mechanical waves that require a medium to travel through. They are longitudinal waves where the displacement of the medium is parallel to the direction of the wave. So sounds are produced by objects that are vibrating. We hear sounds when these vibrations traveling as sound waves reach our ears. This figure shows how it happens. The loudspeaker vibrates and produces sound waves. This sound wave then comes to our ears. So the formula for sound waves is the same as for the speed, which is speed is equal to distance divided by time. Let's look at an example. A girl stands 100 meters from a tall building clapping her hands each time she hears an echo of her clap. It takes 11.7 seconds for her to hear 20 echoes. We have to calculate the speed of the sound. So, speed of the sound will be equal to V equal to S divided by T, where V is the speed of the sound, S is the distance, and T is the time. So, it would be 100 meters multiplied by 2 into 20 divided by 11.7 seconds, which will be equal to 342 meter per second. Now, we have to understand why we multiplied 100 by 2. For an echo to happen, the sound will at first hit the building and then come back. So the distance would be 100, and while it goes to the building, and then when it comes to her ear, it is another 100. So we have to multiply 100 by 2. And since she hears about 20 echoes, we have to multiply that too. So in total, the distance is 200 and she hears it 20 times. So we have to multiply it by 20. The answer comes out as 342 meters per second. While working with sound waves, we have to keep in mind that sound waves reflect off surfaces, creating echoes. For example, a sound wave reflects off a wall 34 meters away. So how long would it take for the echo to return? The solution to this would be the same formula, which is V is equal to S divided by T. Here we have to calculate the time. So T would be equal to S divided by V. So time equal to 68 meters divided by 343 meters per second, as the speed of the sound in air is 343. So the time would be 0.198. We have to remember while working with sound, we will always take the speed of the sound as 330, or if it's given in the question, that's a different thing. Like all other waves, sound waves also have three properties of the wave, which are reflection, refraction, and diffraction. We already spoke about echo and how echo happens. Echo happens basically when we speak or some kind of sound is produced, it hits a barrier and comes back. So from the previous videos, we already know that bouncing back from a surface is known as reflection. So let's learn how diffraction happens in sound waves. When a sound wave meets an obstacle, such as a wall or a barrier, the wave bends around the edges of the obstacle and reaches behind it. This bending basically allows the sound to reach areas that would otherwise be in the shadow of the obstacle. So suppose this is an obstacle, the sound waves basically go around the obstacle, which is known as the diffraction. So when diffraction happens, the sound waves sometimes sound frequency reduces, and we would not hear it as loud as it normally would be. So that is how diffraction basically happens in sound, bending of the waves around the obstacle. In the case of reflection, it is not possible to see sound waves being refracted. We can sometimes hear their effect. While standing at the edge of a pond or a lake, we can sometimes hear the other side, what's happening at the other side of the pond. Let's look at a figure to understand this. In this figure, we can see that there's a refracted sound waves are passing from one path to another. So here the points are most of the sound we hear travels to us in a straight line, which is the path B. But some sound travels upwards, which is the path A. If the temperature conditions are right, then the sound waves travel through the air, they are refracted and follow a curved path downwards, which is the path C. We now receive two sets of waves. so the sound we hear seems more louder and clear. This is basically due to refraction. We have already learned about some formulas for the waves. So let's see how those formulas are used regarding sound waves. In example 2, the picture of a sound wave seen on an oscilloscope has a time period of 0.005 seconds. What is the frequency of the wave? So we know frequency is equal to 1 divided by the time period. So the answer would be 1 divided by 0.005 seconds. So it would come out as 200 Hertz. In example 3, we have to calculate the wavelength of a sound wave that is produced by a source vibrating with a frequency of 85 Hz. The speed of the sound in air is 340 meters per second. We have to notice that if the speed of the sound is given in the question, we have to use that. If it is not given, we will use 330. But here it is given that the speed of the sound is 340 meter per second. So the formula for speed is V is equal to F divided by lambda, which is frequency multiplied by the wavelength. So 340 is the speed, 340 is equal to 85 Hertz, which is the frequency, which we have to multiply it by the wavelength. So we have to calculate the wavelength. So wavelength would be equal to uh, speed divided by frequency. So 340 divided by 85 Hertz. The answer would come out as 4 meter. So the wavelength is 4 meter in the question. Let's learn about some features of sound waves, which are the pitch, loudness, and the audible range. Frequency basically determines the pitch of the sound. The higher the frequency, the higher the pitch. Pitch is basically the measure of frequency determined by the hertz. Loudness, however, depends on the amplitude. Loudness or the volume of the sound is proportional to the amplitude. Greater amplitude means louder sound. Lower amplitude means less sound. So the last feature of the sound waves are the audible range. It is a range of how much humans can basically hear. The average person can only hear the sounds that have a frequency of higher than 20 Hz but lower than 20,000 Hz. This spread of frequency is called the audible range or hearing range. The size of audible range varies slightly from person to person, but usually becomes narrower when we get older. We can see that we have to speak louder to older people at certain times. We can demonstrate this range by using signal generator and a loudspeaker to produce sounds for different frequencies. The audible range for animals also vary from one animal to another. For example, bats can hear a lot more than we do. They are very sensitive to sounds. Even dogs, we can see that when fireworks happen in the sky, dogs usually hide or scream because they hear the fireworks louder than we do. That's all for today, students. So we have learned about how sound waves reflect, refract, and diffract. We have learned about the features of sound waves, and we have also learned how the formulas of waves can be used to calculate problems regarding sound waves. Stay with us to learn more about physics and other subjects as we post regularly on our channel. To learn more about our online tutoring service, do visit www.quickstudy.uk.